We are witnessing two revolutions colliding at full speed. On one side, artificial intelligence, evolving faster than anything humanity has ever built. On the other, the global energy transition, our race to decarbonize the planet. And right at the intersection, a plan so audacious it almost sounds like science fiction. OpenAI and NVIDIA, two giants of the tech world, have announced a plan to build 10 gigawatts of AI computing power. To be clear, this is the single largest AI infrastructure project in human history. The question is no longer just how fast AI can grow, but how cleanly it can grow. Can our already strained clean energy system possibly keep up with the AI boom? Let's rewind to October 2025. This is when NVIDIA's CEO, Jensen Huang, called it the biggest AI infrastructure project in history. It's a partnership combining NVIDIA's cutting-edge hardware with OpenAI's revolutionary software, all to create a global compute network that will make today's ChatGPT look like a pocket calculator. The plan involves a staggering $100 billion investment from NVIDIA to deploy 10 gigawatts of GPU-powered infrastructure. The first gigawatt is set to go live in 2026, running on NVIDIA's next-generation Vera Rubin platform, chips specifically designed for hyper-efficient AI. But what does 10 gigawatts actually mean? It's not just a number, it's a planetary-scale power draw. 10 gigawatts is enough electricity to power roughly 10 million homes. It's the output of 10 nuclear reactors or hundreds of massive solar farms. This kind of demand doesn't just plug into the wall. It reshapes entire energy grids and power markets. This raises the most urgent question of all. Where is all this energy going to come from? The big announcement celebrated scale, performance, and innovation, but was conspicuously silent on energy sourcing. Neither OpenAI nor NVIDIA has specified whether this massive AI ecosystem will run on renewable power, carbon-intensive grids, or some mix of the two. And that silence is deafening, because as artificial intelligence scales up, so does its carbon footprint. Today, data centers already consume about 3% of global electricity and are responsible for 2% of total emissions. That's more than the entire airline industry, and that was before the recent explosion in AI workloads. Training a single large AI model can consume gigawatt-hours of power. Now, multiply that by millions of GPUs, running 24/7 across thousands of servers, and you start to grasp the monumental scale of this challenge. So when OpenAI and NVIDIA talk about 10 gigawatts of compute, they are also talking about 10 gigawatts of continuous, unending energy demand. This makes it not only the biggest AI project in history, but potentially one of the most energy-intensive endeavors ever attempted by humanity. The tech world likes to talk about compute as something abstract, floating magically in the cloud. But there is no cloud. There are only data centers, power lines, turbines, and fuel sources. Every single AI-generated word, image, or idea is powered by real electrons. And those electrons have an origin story. Some are clean, some are not. Here's the core of the problem. AI's growth curve is skyrocketing exponentially. At the same time, while clean energy capacity is also growing, it's on a much more linear, slower path. It's not expanding nearly fast enough to absorb a surge like this. Every megawatt of power diverted to run AI models could be a megawatt that doesn't go to electrifying homes, charging electric vehicles, or decarbonizing heavy industry. This is the paradox of progress. The smarter our technology gets, the hungrier it becomes for energy. But it's not all doom and gloom. The potential for synergy here is enormous. If this 10-gigawatt project fully commits to renewable power, it could trigger some of the largest clean energy investments in history. We're already seeing data centers co-locating with wind and solar hubs, from the wind corridors of Texas to the hydro-powered grids of Scandinavia. Why? Because clean power offers stable, low-cost electricity. If NVIDIA and OpenAI pledged to run their new AI clusters on renewables, they could fund a massive wave of green energy infrastructure around the world. It's happened before. Big Tech's insatiable appetite for data already turned companies like Google, Microsoft, and Amazon into the world's largest corporate buyers of renewable energy. They signed huge power purchase agreements to match their cloud operations with clean generation. NVIDIA and OpenAI could take this playbook and supercharge it. AI at scale, powered by renewables at scale. Of course, it won't be easy. Clean energy has its famous intermittency problem. The sun doesn't always shine, and the wind doesn't always blow, but AI workloads demand constant, uninterrupted uptime. Bridging that gap requires massive energy storage, smarter grid optimization, and potentially baseload support from sources like next-gen nuclear or green hydrogen. 10 gigawatts of AI doesn't just need electrons, it needs reliable electrons 24/7. This challenge opens the door for incredible new synergies between energy and AI. For example, hydrogen fuel cells can provide long-duration backup power without the emissions of traditional diesel generators. And AI itself can be part of the solution. It can optimize how data centers consume power, predict renewable generation with incredible accuracy, and balance electrical loads in real time. NVIDIA's own GPUs are already being used to simulate grid behavior, forecasting solar variability, and optimizing wind power. In other words, the very same computers driving this energy demand could also help stabilize the clean grids that power them. Still, the sheer scale of the challenge is unprecedented. Building 10 gigawatts of AI compute could consume over 80 terawatt-hours of electricity per year. That's roughly the annual consumption of the entire country of Austria. Unless that power is 100% renewable, it could mean tens of millions of tons of new CO2 emissions every year. The pressure is now on NVIDIA and OpenAI to show us the plan. How will they align this digital revolution with the global imperative for decarbonization? There are some hopeful clues. OpenAI's cloud partner, Microsoft Azure, has already pledged to be powered by 100% renewable energy by 2025. And NVIDIA's upcoming Vera Rubin GPUs promise major gains in performance per watt, meaning faster AI with less energy. But efficiency alone won't solve this. Even with the most efficient chips in the world, 10 gigawatts is still 10 gigawatts. The real question is how those watts are generated. Analysts predict that these new data centers will be built across multiple continents, strategically placed in regions with strong renewable grids, like hydro-powered Scandinavia, solar-rich North Africa, or the wind corridors of the U.S. Southwest. Others warn that the need for speed and existing infrastructure might push them towards fossil-heavy grids in Asia or the U.S. Midwest. Either way, this has become much more than a tech story. It's a planetary energy story. AI isn't just code in the ether. It's becoming a new industrial sector with an energy footprint to rival heavy manufacturing. The race to build smarter machines is now inseparable from the race to build cleaner grids. And this is where a wild card enters the picture: green hydrogen. Hydrogen offers high-density, zero-carbon storage for intermittent renewables like solar and wind. Pairing green hydrogen systems with AI data centers could create a source of constant, reliable, clean power. Imagine using surplus solar energy to create hydrogen, storing it, and then converting it back to electricity whenever needed. This isn't a fantasy. Engineers are already designing hydrogen turbine microgrids for data centers. If NVIDIA and OpenAI embrace this, their 10-gigawatt project could become a global prototype for AI powered by hydrogen, clean, flexible, and scalable. But for now, that vision is hypothetical. The announcement was heavy on ambition but light on sustainability details. And that gap is what has the world watching. This isn't just about being environmentally responsible, it's about smart economics. Energy is a cost, and power bills are one of the biggest expenses for any data center. What was once considered a premium, clean energy is now the cheapest source of new power in most of the world. Aligning AI growth with clean energy isn't just good for the planet, it's good for the bottom line. The greatest challenge remains speed. The International Energy Agency says we must triple renewable energy deployment by 2030 to meet our climate goals. If AI infrastructure doubles or triples power demand before then, it could create massive bottlenecks, unless these two revolutions are closely coordinated. We are entering a powerful feedback loop. AI accelerates clean energy innovation, and clean energy enables AI's expansion. The balance between the two will define the next decade. As AI becomes more integrated into our lives, its invisible energy footprint will come under scrutiny. Consumers, investors, and regulators will all be asking the same question. Can clean energy keep up with AI's hunger? The answer depends on choices being made right now. It depends on where data centers are built, how grids evolve, and which fuels we choose to power our future. NVIDIA and OpenAI's 10-gigawatt bet is not just on the future of AI, it's a bet on the future of energy itself. In the end, an intelligence that ignores the physical limits of our planet isn't truly intelligent at all. The next frontier of AI won't be measured in GPU counts or model size. It will be defined by watts per thought, how efficiently we turn energy into intelligence, and whether those watts come from coal or sunlight will determine if this revolution is sustainable. The world is watching. To explore how hydrogen, renewables, and AI innovation are shaping a sustainable future, visit our partners at H2 Hub. Energy. Thanks for watching. If you found this insightful, please like, subscribe, and hit the bell to stay updated. See you next time.